We're in section 6.4, and in section 6.4 we're dealing with squares. You have two rules for squares. If you have the difference of squares, which means they're minus, you have a square on the front, a square on the back, and a minus in between them, you factor like the formula that you see on your notes. But if you have the sum of squares, it does not factor. So your directions are to factor completely. Our first one is x squared minus 25. I recognize that to be the difference of squares. So that means I'm going to have an x and an x on the front, and a 5 and a 5 on the back. Since it ends with a minus, that means my signs are different. One's positive and one's negative, and that's how it would factor. Your second rule at the top of the page says that the sum of squares, which means adding, the sum of squares does not factor. So this example here, x squared plus 4, it will not factor, and so it's called prime. And the reason it doesn't factor is that you have a plus there. The sum of squares does not factor. Okay, so let's look at a few other examples from this section. Okay, I'm asking you to factor completely, and your first one is 16x squared minus 49y squared. 16 is a square, x squared is a square, 49 is a square, and y squared is a square, so everything is a square. The number squared that makes 16 is 4, so you would have 4x times 4x, and the number squared that makes 49 would be 7, so you'd have 7y and 7y. One's positive and one's negative. Your second one is tricky. You have x to the fourth minus 81. X to the fourth is a square and 81 is a square. When you work this one, you have x squared times x squared, because x squared times x squared is x to the fourth. The number squared that gives you 81 is 9, so we have 9 and 9. And remember, your signs are plus and minus. Now I recognize x squared and 9 to be squares again, so remember your rule. The sum of squares does not factor. So that means I just can bring this one straight down. That's all I can do with it. It does not factor. But if you look at the other one is the difference of squares, and the difference of squares does factor. So I have an x and an x, and a 3 and a 3, and notice that my signs are different. One's positive and one's negative. So this entire expression, x squared plus 9, x plus 3, x minus 3, would be your answer. And again, the first factor, x squared plus 9, does not factor because it's the sum of squares. The next one you see on your paper is 5x squared minus 20, and this one is special because it has a GCF. So the first thing I'm going to do with this problem is see what they have in common, and I notice they both have a 5 in common. So I can take out the 5, and when I do, it leaves me with x squared minus 4. X squared minus 4 is the difference of squares. So I'm going to bring down this 5 again, open my parentheses, and I have x and 2 and 2, and one's positive and one's negative. It kind of went off the bottom of the screen, so I'm going to rewrite it. So your final answer for this particular problem would be 5 times x plus 2 times x minus 2. My next one also has a GCF, 2x squared minus 50x. I notice that this one has a 2 and it also has an x. So my GCF is 2x. When I factor that out, what's left behind is x minus 25. And that's your answer. Now, some people say, well, why doesn't it factor again? You have x and you have 25. 25 is a square. It is a square. But since this x right here is a plain x, Since it's a plain x, it's not going to factor again. The only time that would factor again is if you had x squared, and you don't have an x squared there. So this one is just a GCF. That's all that you can do with that one. Take the GCF and stop at that point.